Calculus, stationary points. So before we calculate the stationary points, or before we go further, we need to understand what are stationary points, or what is the stationary point. So a stationary point, it is any point on a curve where the gradient is 0. That is what we call stationary point. So that is what we call the stationary point. So what are the steps we need to follow in order to find the stationary point? Number one. So step number one, you need to find what we call the first derivative, which is dy dx. So that is step one, find the first derivative, which is dy dx. Then step two, you need to solve for x by saying dy dx is equal to 0. So dy dx is the gradient. Remember, the stationary point, it is a point on a curve where gradient is 0. So this is gradient, dy dx is gradient. So gradient is equal to 0. So from there now, you need to find the values of x coordinate of any stationary point. Then point 3, you need now to substitute the values of x into the equation of the curve to find the corresponding values of y coordinates. So this is the turning point. So at this turning point, gradient is 0. So dy dx is equal to 0 at this point. At this point, dy dx is equal to 0. So we call this as the local minimum point, and we call this as the local maximum point. Examples: find the coordinates of the stationary points. At A, y is equal to x squared minus 2x plus 2. Remember the steps. The first thing that we need to do, so we need to find the first derivative, which is dy dx. So I'm going to differentiate this equation. So it is going to be dy dx equals. So how do we differentiate? Remember, two principles. The first one, so how do we differentiate in this case? So how do you differentiate this one? So you say dy dx is equal to 2, which is the power, times x, which is this x. Then you reduce this 2 by 1. So you say 2 minus 1. So there we say 2 times x, it is 2x. 2 minus 1, it is 1. But we don't write the power of 1. So differentiating x to the power 2, it is 2x. So x to the power 2, that is our 2x. So how do we differentiate 2x? So remember here, it is power 1. So this is power 1. So 1 times 2, it is 2. Okay? So 1 minus 1, it is 0. So x to the power 0, it is 1. Okay, so differentiating 2x, it is 2. Then differentiating a constant, it is 0. So there is no need for us to put a 0 there. So how do you differentiate 2x? So you say dy dx is equal to, so this is power 1. So you say 1 times 2, 1 minus 1. So you reduce the power by 1. So you say 1 times 2, so 2x. So 1 minus 1, it is 0. So now any number or letter to the power 0, it's 1. So 2x to the power 0, it is 2. So now from there, now we are going to solve for x. So remember that stationary point gradient is 0. So dy dx is equal to 0. So where there is dy dx, I'll substitute 0. So I'll say 2x minus 2 is equal to 0. Here I can just correct the like terms. So we are going to correct the like terms. So this is negative 2. When it goes this side, it will be positive 2. So you say over 2, over 2. 2 goes. So 2 into 2, that is 1. So the value for x coordinate, it is 1. So now the next step is we are going to find the corresponding y coordinate by substituting this value of x into the equation. So the equation is y is equal to x to the power 2 minus 2x plus 2. So where there is x here, I'm going to substitute 1. So it will be 1 squared minus 2, 1 plus 2. So I'll say y is equal to 1 squared, that is 1, 2 times 1, that is 2, plus 2. So the value for y is equal to 1 minus 2, that is negative 1. Negative 1 plus 2, that is 1. So the value for y is 1. So now the coordinate now. So the coordinate, it is 1, 1. So that is the coordinate for the stationary point. So B, the first thing that we are going to do, it is to find the first derivative, which is dy dx. So dy dx is equal to, so you say 3 times x, you reduce 3 by 1, then minus this power here, you multiply 3 over 2, x, you reduce the power by 1. So remember that we are differentiating. So you say dy dx is equal to 3 times x, that is 3x, 3 minus 1, that is 2. So this 2 and this 2 goes. Okay, we remain with 3. So minus 3, 2 minus 1, it is 1. But we don't write that power of 1. So remember that we are looking for the stationary point. So dy dx is equal to 0. Okay, so we are going to say 3x squared minus 3x is equal to 0. So dy dx is equal to 0. So from there now, I'm going to factorize. So 3x is common. So 3x is common. Remember that I'm looking for the values of x. So how do we find the values of x in this case? So in this case, you factorize. This is quadratic factorization. So 3x into 3x squared, it is x. 3x into 3x, it is 1, is equal to 0. So from there now, I'm going to make two equations. Equation 1, it will be 3x is equal to 0, or x minus 1 is equal to 0. We call this as the zero product. So there we say over 3 over 3. So 3 goes. So 3 into 0, it is 0. Or this is negative 1. When it comes this side, it will be positive 1. So we have the x coordinates. So for us now to find the y coordinates, we need to substitute these x coordinates into the original equation to find the corresponding values of what? Y. Remember that the equation is given by x to the power 3 minus 3 over 2 x to the power 2. So let's now substitute the value of x, which is 0. What is the value of y when x is 0? So y is equal to where there is x, we substitute 0. Where there is x, we substitute 0. So y is equal to 0. Then now let us substitute where there is x, we substitute 1. Is equal to 1 to the power 3 minus 3 over 2, 1 to the power 2. So y is equal to 1 to the power 3, it is 1. 3 over 2 times 1 to the power 2, it is 3 over 2. So y is equal to negative 1 over 2. So now for the coordinates, when x is 0, y is 0. So this coordinate, it is going to be 0, 0. For the coordinate when x is 1, then y is equal to negative 1 over 2. So those are the two coordinates that we have. So 0, 0, and we have 1, negative 1 over 2. So those are the two coordinates that we have. So part C, the first thing that we are going to do, we find the first derivative by saying dy dx is equal to, so 3 times x, we have 3x, 3 minus 1, we have 2, 2 times 3, we have 6, 2 minus 1, we have 1. So 1 times 9, it is 9. 1 minus 1, it is 0. So x to the power 0, it is 1. So that is our first derivative. So in this case, remember that dy dx is equal to 0. I'll say 3x squared minus 6x minus 9 is equal to 0. So I'm going to solve for x. But before I solve for x, 3 can go into 3, it can go into 6, it can go into 9. So I'll say over 3, over 3, over 3, over 3. So 3 goes, I remain with x to the power 2, 3 into 6. So 3 into 6, it is 2x. 3 into 9, we have 3. So 3 into 0, we have 0. So from there now, this is quadratic factorization. So this is sum, this is product. So we are going to find the factors of 3. So factors of 3, we have 1 and 3. So from here we are going to have two numbers. When we add, we are going to have negative 2. When we multiply, we have negative 3. So sum, so it will be negative 3x plus x. So this is 1x, which is 1. This 3, that is negative 3. I'm going to have negative 2x, which is this negative 2x. Then the product is going to be negative 3 times 1, which is negative 3. So I'll just substitute where there is sum 2x. I'll substitute with negative 3x plus x. So x squared minus 3x plus x minus 3 equal to 0. So I'm going to group. So x is common. X into x squared, x. X into 3x, 3. So 1 is common there. 1 into x, that is x. 1 into 3, it is 3, is equal to 0. So there we have x plus 1. And we have x minus 3 is equal to 0. So I'm going to make two equations. Equation 1, it will be x plus 1 is equal to 0, or x minus 3 is equal to 0. So this is positive 1. When it goes this side, it will be negative 1. This is negative 3. When it goes this side, it will be positive 3. So we have the x coordinates. So the next thing is we are going to find the y coordinates, the corresponding y coordinates by substituting. Where there is x in the equation, we substitute negative 1. We also substitute 3. So the equation is y is equal to x to the power 3 minus 3x to the power 2 minus 9x. So what is the value of y when x is negative 1? So y is equal to, positive 5. So when x is negative 1, y is 5. So the coordinate is going to be negative 1, comma 5. Now let's go when x is 3. So y is equal to, where there is x, we substitute 3. So it will be 3 to the power 3 minus 3, 3 to the power 2 minus 9 times 3. So y is equal to 3 to the power 3, that is 27. 3 to the power 2, that is 9. 9 times 3, 27. So negative 9 times 3 is negative 27. So the answer is negative 27. So the coordinate becomes 3, negative 27. So you can try E and C.